Additional facts. Extra facts other people might enjoy. Galileo's observations provided strong evidence that the Earth revolves around the Sun, supporting Copernicus' theory, which was controversial and opposed to Church's geocentric view at the time. Other work Galileo did. He pushed the idea that an object in motion keeps moving unless something stops it. This sets up Newton's first law. Scientists connected to Galileo. Nicholas Copernicus. Galileo's astronomy arguments built on Copernicus' heliocentric model. Other things people should know. Galileo's spacecraft launched in 1989 explored Jupiter and its moons, a fitting tribute to the men who first saw them through a telescope. Additional interests. Things I found interesting. I found interesting that the whole setup of Galileo's speed of light experiment, he proposed putting two people on distant hilltops with covered lanterns. Person A uncovers their lantern, person B uncovers theirs as soon as they see A's light, A times the delay. What I learned compared to what I thought. I thought the lantern setup might produce a noticeable delay so Galileo could calculate a real speed for light even if it was rough. I actually learned that the delay over hilltop distances is far too tiny for humans to time. The experiment mostly shows if light isn't instant, it's still insanely fast, so fast that reaction time dominates the result and makes measurement impossible with that method. What I would investigate with more time. I would investigate whether temperature/pressure changes and turbulence measurably affect timing or beam spread over long outdoor paths. Overall summary. Overall, the project went pretty smooth. I learned so much about Galileo's speed of light. I think after I chose my example for Galileo's speed of light, the project was a breeze because I was able to easily put the slides together. The most important part was really understanding that light isn't instant. It travels at incredibly large speed, and that speed acts like a hard limit for how fast information and cause and effect can move. I think the easiest part was choosing my example for Galileo's speed of light. I wanted my slides to be based off of because I fully understood the example. I was able to easily talk about the history and connections to real life. I think the hardest part was coming up with a numerical problem because I had to make sure it had a real solution and that it wasn't too difficult. I was most surprised learning that when light passes near massive objects, its path bends due to gravity. This lets astronomers see distant galaxies hidden behind others. Relevant sources. Original source for 1.4 Part B. Original excerpt. Galileo Galilei was born 15 February 1564 near Pisa, the son of a musician. He began to study medicine at the University of Pisa, but changed to philosophy and mathematics. In 1589, he became a professor at mathematics at Pisa. In 1592, he moved to become a mathematics professor at the University of Padua, a position he held until 1610. During this time, he worked on a variety of experiments, including the speed of which objects fall, mechanics, and paralamps. Why this source was useful. This source was useful because it gave me everything I needed to know about the science of Galileo Galilei and gave me facts to be able to input into my slides. Where was it used? It was used in 1.4 Part B, Relevant Sciences, to give facts details about his life. These are the sources I used for Part B and Part C.
Additional facts. It takes approximately 8.5 minutes for the light of the sun to reach Earth. And then what else was Foucault able to discover? He proved that Earth rotates on an axis. And then Foucault was not the original scientist for the speed of light. However, he was able to give an exact measurement for the speed of light through water. Additional interest. I found it interesting how many different scientists it took to find out the measurement for the speed of light. And then I thought I would just learn about the speed of light through air. I had no idea my research would take me to the water. And then what would I like to study in my free time? Foucault's life. I am in lecture physics 2, and for my project and lecture, I have also been having to study Foucault. Overall summary. I think the most important part is to know how the speed of light moves through space, water, and air. And the easiest part of this project has been Part A and Part E, and then the hardest part was Part D. And then what have I learned is how bad I procrastinate. Relevant resources. These are 2 sources I used. Both sources helped me with Part C and Part D. They helped me understand how the rotating mirrors work and also helped me produce my brand unique problem. And then my screenshot for this slide is the slide from my any unique problem.
My additional facts include that the speed of light is the ultimate speed limit for the universe and that nothing can travel faster. Christian Huygens discovered Saturn's moon Titan, and he also discovered that Saturn has rings. His discoveries of Saturn were based off the findings left by Galileo. I thought it was interesting how complex yet sustainable the studies regarding the speed of light have been. I was also surprised at how many different ways there were to experiment with the speed of light. I'd like to study what factors, if any, are involved with the speed of light in space. For my overall summary, I think the project was overall fluent and well done by the group. The most important part of the project to me was the punctuality of submitting the project pieces. The easiest part was findings for the project, and the hardest part was pacing myself well when recording for the project. Here listed are the relevant sources that I used within this project.